welcome to Let's Go. Today we will discuss an important chapter of class 12 CBSE board electronic devices. We will begin this chapter with the topic energy band in conductors, insulators and semiconductors. What are energy bands? Energy bands are different energy levels in any crystalline material or solid substances. There are three types of energy band: conduction band, valence band and forbidden energy band. All free electrons are present in the conduction band and the valence electrons are present in the valence band. And the forbidden energy gap is the amount of energy required to jump the electrons from valence band to the conduction band for conduction. Or we can say that forbidden energy gap is the energy difference between the conduction band and the valence band. Here in the diagram we can see that first we will begin with the topic energy band in case of conductors. Energy band in conductors we can see in this diagram. In conductors, the conduction and the valence band overlap with each other. In conductors, there are already free electrons, so there is no energy required to make electrons free by jumping from valence band to the conduction band. Electrons are already free in case of conductors. So there is very less or no forbidden energy gap between the conduction band and the valence band in case of conductors. We can see in the diagram, the both bands are overlapping with each other. This conduction band and the valence band. Both are overlapping with each other. It means that there is no energy gap or forbidden energy gap in case of conductors. Now we can see that in insulators, second is semiconductor, energy band and semiconductor. And in energy band in semiconductors, the forbidden energy gap is very less than 3 electron volt. So there is very less amount of energy required to jump electron from valence band to the conduction band. When the substance or the semiconductors are heated or energy is provided to the semiconductors, then the electrons from the valence band jump to the conduction band and are free for conduction. They become free in conduction band and start conducting in case of semiconductors. So we can say that the forbidden energy gap in case of semiconductor is less than 3 electron volt. So when a heat energy is provided to the semiconductors, the electrons from the valence band jump to the conduction band and start conducting. We can see here for different semiconductors, the forbidden energy gap is different. For silicon, the forbidden energy gap is 1.12 electron volt, and for germanium, the forbidden energy gap is 0.75 electron volt. Now we will discuss the energy band in insulators. We can see that the forbidden energy gap in case of insulator is very large than 3 electron volt. So this is very large energy which is required to jump electron from the valence band to the conduction band. So the conduction in case of insulators is not possible because this is a very huge amount of energy which is required to make electron jump from valence band to the conduction band. So they are the three types of energy band: conduction band, valence band and forbidden energy gap in case of conductors, insulators and semiconductors. In conductors, the both conduction band and the valence band overlap with each other. In case of semiconductors, the gap between the conduction band, energy gap between the conduction band and valence band is less than 3 electron volt. And in case of insulators, the energy gap is more than 3 electron volt. Now, next topic is types of semiconductors. There are two types of semiconductors: intrinsic semiconductor and extrinsic semiconductor. Pure semiconductors are called intrinsic semiconductors, in which the number of charge carriers are equal. There are two charge carriers in case of semiconductors: electrons and holes. In case of pure semiconductor, intrinsic semiconductor, the number of charge carriers are equal. At 0 Kelvin, these intrinsic semiconductors behave as an insulator. But when temperature is increased, then electrons hole pair are created in these semiconductors and conductivity increases. Second type of conductor is extrinsic semiconductor. What are extrinsic semiconductors? Impure semiconductors are called extrinsic semiconductor. When we add impurities to intrinsic semiconductors, then the conductivity of the semiconductor increases, and these types of semiconductor are called in extrinsic semiconductor. By adding the impurity, conductivity increases, and conductivity is controlled by the dopant. And the amount of impurities, by adding amount of impurities, we can also control the conductivity of semiconductors. There are two types of extrinsic semiconductor. First is N-type semiconductor and second is P-type semiconductor. What are N-type semiconductor? The N-type semiconductors are formed by adding pentavalent impurities to intrinsic semiconductors. What are pentavalent impurities? These are those impurities atoms which have 5 valence electrons. See, generally the semiconductors like silicon, we can take the example of silicon. Generally, the semiconductor like silicon has 4 valence electrons. Now, when we add the pentavalent impurities like phosphorus, phosphorus has 5 valence electron. With 4 valence electron, it makes bond with the silicon. Fifth valence electron remains free for conduction. So, in case of N-type semiconductor, the majority charge carriers are electrons, which are responsible for conduction. Majority charge carriers are electrons in case of N-type semiconductors. So N-type semiconductors are formed by adding pentavalent impurities. Pentavalent impurity, that's phosphorus atom, which have 5 valence electrons. Here the majority charge carriers are electrons. Now we will discuss about the P-type semiconductor. P-type semiconductor are formed by adding the trivalent impurities. Trivalent impurities which are having 3 valence electrons. Like we can take the example of silicon again. Can make bond 4 atoms. When we add trivalent impurity atom like aluminium, aluminium has 3 valence electron, and here remain the one bonding free. This create a hole, and now this hole will be responsible for the conduction in case of p-type semiconductor. So here the majority charge carriers are holes. In case of p-type semiconductor and n-type semiconductor, majority charge carriers are electrons. These are two types of semiconductors, N-type semiconductor and P-type semiconductor. N-type semiconductors are formed by pentavalent dopant atoms, which are found in group 15 of periodic table, and group 13 periodic table are formed trivalent atoms, which are responsible for the formation of P-type semiconductors. Now we will discuss about the semiconductor diode. What are semiconductor diode? Semiconductor diode, when P-type semiconductor and N-type semiconductor are joined together, then this forms the P-N junction diode or PN diode. PN junction diode is formed by joining P-type semiconductor and N-type semiconductor. We will discuss about the biasing of PN junction diode. Biasing is simply connecting the PN junction diode with the battery. There are two types of biasing, forward biasing and reverse biasing. When this P-type semiconductor